so we're going to do complex conjugates. And if we start with the word complex, we talked about yesterday what complex numbers are. What's a complex number? Wait a minute. Yeah, it's a real number like 3 mixed with an imaginary number like 2i. Okay, a complex number. And then we're going to take complex and add the word conjugate, which you know the meaning of a conjugate, right? Give me an example of a conjugate. What does that mean when I'm saying a conjugate? Two things are conjugates of each other. What changes between them? The plus and minus, right? So it's kind of like saying if you have 3 plus 2i, that's a complex number, right? A real and imaginary. It would change to 3 minus 2i. Right? It's conjugate. What about if you have 5i? Its conjugate would be negative 5i. So if I told you 1 plus 6i divided by 5i, before we start anything, we talk about the fact that there's an I in the denominator. Okay? What is the value of I? I is the same thing as what? The square root of what? Negative 1. So what I have here probably is the square root of the negative 25. Correct? Because inside I've got negative 1 and I've got 25. So the 25 becomes 5 and the square root of negative 1 becomes I. So when you see I in the denominator, technically, what's there? A radical. Excellent. Okay? A radical. So I've got to get it out. Okay? To get it out, the only way to get rid of I is to multiply it by another I. Because I times I is what? I squared, good, which is negative 1. Remember, we talked about that because we said, okay, if you did this, the radical just drops, right? Just like if I said square root of 3 times square root of 3, the radical drops and gives you 3. Square root of negative 1. Okay, so that's our goal, is to get rid of the I. Now, if I want to get rid of I in the denominator, I'm going to multiply by the conjugate, which would mean multiply by negative 5i. So in the denominator now, 5 and negative 5 make negative 25, and I make I squared. And I squared is the value of negative 1, so this is actually negative 25 times negative 1, which is positive 25 now. In the numerator, you're going to have to distribute this to both. So you have negative 5i minus 30i squared. What's an I squared turn into? Negative 1, so this is actually positive 30. When we write our answers, we do real and then imaginary. So I'm going to put the 30 first, and then 5i last. And you'll notice we can simplify it. Well, of course, we multiply the entire fraction by 5. So what do you think we're going to have to divide by? 5 again, right, to simplify. So divide everything by 5, and you'll get 6 minus I over 5. Number 2. We have 6 plus 5i over negative 2i. What are you going to multiply by? 2i. We have to multiply both the bottom and the top because really we're just multiplying by 1, right? 2i over 2i is 1. It's just going to make it look more acceptable, okay? On the denominator then, you're going to get negative 4i squared. And in the numerator, you have to multiply the 2i by both to give you 12i plus 10i squared. Negative 4 times negative 1, this actually has a value of plus 4, positive 4. This has a value of negative 10. In the numerator, we have negative 10 plus 12i divided by 4. What fits into all three of them? 2. Excellent. So now I actually have negative 5 plus 6i all over 2. Number 3. 2 over 7 minus 8i. What's your opinion here, guys? Let me give it a shot. Good job. Multiply by the conjugate, right? If I multiply by I, that'll multiply the whole thing by I. It would help me here because then I'd have I squared. But over here I'd have 7i. It wouldn't get me anywhere. I need the i's to cancel. I need the middle terms to cancel. So multiply by its conjugate. So multiply by 7 plus 8i. When I FOIL, then because the denominator is conjugates and I know my middle terms are going to cancel, instead of FOILing, I can just do first and last. First and last. So 49 minus 64i squared. In the numerator, multiply 2 by both. To give me 14 minus 16i. Plus 16i, sorry. The bottom right here can be cleaned up a little. This would be a positive 64. Giving us in the numerator 14 plus 16i over a 49 and a 64 make 113. I can't reduce it. So you're done. Does anybody, this is a side note, but does anybody remember how to check like a huge number to see this divisible by 3? Like if I want to know if 2050, I'd help if I had another, there you go, 2500. If I want to know if 2500 is divisible by 3, what's the trick? Okay, see that.
You add them all up and see if they can come.
Good. So 0 plus 0 plus 5 plus 2 is 7. Does 3 fit into 7? No, so 3 doesn't fit into 2500 either. Isn't that a cool trick? So some of you already knew it, but if you didn't know, it's just a... And there's a trick for 6. Okay, this is... Number 4. 9 over 3 plus 4i. You're going to multiply by the what? Again, the conjugate. So on the bottom, you're going to do 3 minus 4i. In the bottom, they're conjugates, so first and last what will be the easiest. So you end up with 3 and 3 to make 9, and a 4i and a negative 4i make negative 16i squared. In the top, 9 times 3 is 27, and 9 and 4 make negative 36i. This becomes positive 16. 9 and 16 make 25. And then 27 minus 36i. 27 and 36 are divisible by 3, but 45 is not. It's 2 plus 5 is 7. Guys, please stop talking. Number 5. Two minus 4i over 1 plus 3i. If I multiply by the conjugate, which it looks like that's what most of you guys are doing, okay, in the denominator, it's the same, first and last. So 1 minus 9i squared. It's the numerator that's different. Because they're binomials, you actually have to do what to them? FOIL. Yeah, they're not conjugates. Okay? So you have to multiply. So you're going to get 2 minus 6i minus 4i plus 12i squared. Then you're going to clean it up a little. This becomes negative 12, and this becomes positive 9. Remember when you simplify the numerator, put the real in the imaginary? So a 2 and a negative 12 are going to give us negative 10, and this gives us negative 10i. In the denominator, we also have 10s. We have lots of 10s. Everything will divide by 10, so you end up with negative 1 minus I. Number 6. 4 minus 2i over 7 minus 3i. Go ahead and start it. Okay, on here, this becomes a plus 6 and a plus 9. Combine your reals together first. So you end up with 28 and 6 giving us 34. And 12 and negative 14 giving us negative 2i over 58. They're all even, so you can divide them all by 17. Okay, now the last two are different a tiny bit. We have 2 more, 7 and 8. So here's 7. It says 30 over 5i root 6. You don't necessarily do anything different, just they look a little different. Is 5i root 6 allowed in the denominator by itself just to hang out? No. We got to get rid of the radical and the I. I know, right? So we're going to multiply by the conjugate because think about it. If I multiply by root 6, it's going to get rid of this. Right? If I multiply by I, it's going to get rid of this. Do you see how the conjugate will work? Because root 6 times root 6 is how much? Be careful. How much? 6. So it's going to work. It's going to drop the radical. So multiply by its conjugate. Negative 5i root 6. 5 and negative 5 are going to give us 25. Negative, sorry. I and I are going to give us I squared. And root 6 and root 6 are going to give us how much? 6. So it's going to clean it up a tiny bit more. What's negative 25 times negative 1? Positive 25. And 25 times 6? 1. For the numerator, 30 and negative 5 make negative 150. Then your I and your root 6. So that just drops over here. What's going to happen with the 150s? They go away, and the answer is just negative I root 6. One more. All right, give it a shot. Multiply by negative 3I root 6. A 3 and a negative 3 are negative 9. I and I make I squared. And root 6 and root 6 make 6. In the numerator, okay, how you do this is up to you. If you want to go ahead and break up root 12 right now, you can. Okay, did anybody break it up right now before they started? How many of you went ahead and did 12 times 6? Most of you? Okay, so we'll go that route then. So then you've got negative 3I root 72, correct? Okay, the denominator, negative 9 times negative 1 is positive 9. 9 times 6 is 54. What did y'all use for 72? Okay, did anybody think to use 9 and 8 and they started there?
Yeah.
Okay, yeah, if you use 9 and 8, it's okay. What ends up happening is you get negative 9I root 8. But can you break up 8 one more time? To get 4 and 2, so it kicks a 2 out to give you negative 18I root 2. If you don't get a number, if you can't think of the biggest that fits in, it's okay, you'll just have to do it twice. 18 and 54 are both divisible by 3. So you have negative I root 2 over